Hi, Tom English, and we're going to finish up on circles. The areas of calculation with circles mainly have to do with finding the area, the circumference, diameter, so forth, and also the length of chords and the relationship of chords within a circle. And that's what I want to cover right now. There's a theorem that says if the radius or diameter is perpendicular to any chord, then just the fact that it's perpendicular to it, that then cuts it in half, or it bisects both the chord and the intercepted arc. Okay, in this case, you may not be able to see the letters, but this is chord DC. It will show it perpendicular to the radius from P, and therefore we're saying that based on this theorem, the chords are equal, as are the intercepted arcs. Well, if this is the case, then I want to go through a couple types of problems that you're going to be asked to solve. And in this particular case, we have an inscribed triangle, and you'll notice that it's an isosceles triangle. And what they're saying is that the arc AC is equal to 140 degrees. So this is 140 degrees, and they're basically asking us to find the arc, the smaller arc, AB. Well, again, the fact that this is an inscribed triangle, it shows that two of the sides are equal. In other words, it's an isosceles triangle. Then that says that this arc is also 140 degrees. And as simple as this problem is, what do we do to find the third, or the minor arc? We're going to add these two arcs together. 140 times 2 is 280, and then just subtract that from 360. So we find that our minor arc is 80 degrees. This third circle is a little different in that it shows, again, two chords, actually three chords. The first chord here, let's say, we're asking us to find x and y, or x and m, and let's indicate that it's perpendicular. Again, the radius is perpendicular to the chord. What did we say back here? If it's perpendicular, it bisects that chord into two equal parts. So if one of those parts is x plus 2, the other is 3x minus 4. All we have to do is set those equal to each other, and it's a simple algebra problem from that point on, and we get then x is equal to 3. In the M situation up above, what we have is two chords, and those chords are shown to be perpendicular to a radius. And again, what happens is the radius says that they are, the radius rather is perpendicular. That says it's going to split them in two. But also if they said that this distance, the distance from the center of the circle, is the same, then we say those chords are equal. Isn't that what we said back here? So if a chord is equidistant from the center with another chord, then those chords are equal. And if those chords are equal, then, and they're both bisected, obviously the parts are going to be equal, and we can set those equal to each other, and we had another simple algebra problem ending up with m is equal to 4. Again, the lesson that we want to emphasize from here is that if a radius is perpendicular to a chord, it cuts that chord in two, it bisects the chord and the associated arc. If the distance is the same, in other words, both chords are the same distance from the center of the circle, measured by these perpendiculars, then those chords are going to be of equal length. So that's the kind of problems you're going to have with circles, other than the area, the circumference, the diameter, and so forth. So hopefully those aren't too tough, and you're going to do well on any test on circles. Thank you.